our Makery schedule for this semester is a little bit different than it has been in past semesters. We usually have a workshop every week, and we used to have project meetings also every week, but then just because of the virtual format, it's a little bit different. So we'll be having workshops on every other Tuesday and projects on every other Thursday, and it would be like alternating. So as you can see on this slide, our schedule will be like as you can see, so the 2nd of February we'll have a Valentine's Day workshop, and we'll be teaching you guys how to laser cut and create like a little LED display stand. The 16th we'll be using photoresistors to create a car that like chases the light, or wherever it sees like the brightest light coming from. And on the 2nd of March we'll have a Raspberry Pi Day competition. It'll also be using the LED matrix. And then the 16th, it's up to y'all if you want to have a meeting. It's technically a school holiday, but if people still want a workshop, we can do that. The 30th will be April Fool's, so we'll be building a useless box, and you can like kind of just build one of those. It's kind of April Fool's like. And for the 13th, we'll be doing a music syncing LED strip to sync with your studying music while you're studying for finals. And on the 20th of April, which will be our last meeting, we'll kind of demo the stuff that we've been working on during our project meetings, and if any of you have like personal projects, you could also demo those. And we'll also be electing people for our officer positions. Okay, so yeah, welcome to our Tuesday 26th meeting. So this is your admin team. I am Mudit, I'm the one that's been talking, and I obviously look extremely different. I have much longer hair and a much bigger beard now. But yeah, I'm a second year CS major. My threads are Intel and ModSim right now. And yeah, go ahead, Jack.
Okay, my name is Jack. I am a second year ME major, so mechanical engineering, but I'm also taking a CS minor, so I'm trying to learn how to code and be like y'all. But yeah, if you guys have any questions, I'm the outreach coordinator. So yeah.
Cool. And we also have a graduate advisor right here. He can come say hi.
Hey guys, I'm the graduate student advisor. My name's Polkit. I founded this club, 4 years ago now. Yeah, if you guys have any questions about like makerspaces around campus or anything like that, I've had a decent amount of experience using all of them, so feel free to shoot me a DM on any of the social media we have, or just shoot me an email or whatever you want to do. Yep.
And our last admin member, Maggie, she was not able to come today, but she'll be here a lot more during our project meetings, which I'll talk about a little bit later. Okay. Where's my mouse? So yeah, I'll quickly kind of describe what we do in the Makery. So we have weekly meetings, and this semester is a little bit different with the alternating Tuesdays and Thursdays, but it'll always be 6:30 to 7:30 on Blue Jeans. And we have the link right here. Jack can send it in the chat. It's gtmakery.github.io/bluejeans. And then if you're not on the email list yet, you can fill out this short survey, tinyurl.com/gtmakerysurvey2021. And that'll just sign you up for the email list, and we also just have a couple quick questions just to make the club a little bit more personalized for what you guys want. So our workshops, I described what they would be at the beginning of today's meeting, but in general they're Arduino, Raspberry Pi, wireless electronics. We do some 3D printing and laser cutting as well. And if you guys have any like special requests about a specific workshop, we can also do something like that. And then our project meetings, which will be on Thursdays this semester, are just like, it's just a time for us to get together and kind of just as a team create something. So right now, one of the projects that we're working on is a go-kart, and I think we have a motor behind me. I can pull it out. But yeah, basically Lime, they had some decommissioned scooters, so we got the motors for those, and we're going to be putting those together to create a little cart. And so here's one of the motors. So this was just basically salvaged off of a scooter, and then here's like all of the wires that would usually be like plugged into like the scooter, but for us, we'll be kind of wiring that up on our own. And yeah, so if you're interested in that, or you want to pitch us a different project idea, feel free to come to any of our project meetings on Thursdays, and we'll do that. And if you missed the schedule for our like when we have workshops and projects, it'll be in the recording. It's just at the beginning of this meeting. I can also pull it up at the end of the workshop. Cool. So I think Jack already sent some links in the chat, but here's just a summary. So for our mailing list, it's tinyurl.com/gtmakerysurvey2021, and then we have Discord, Slack, and then we also have an Instagram and Facebook page. I'm not going to bother reading all the links, but they're in the chat, so if you want to join any of those, please do so, and that'll be kind of where we do a lot of the communication for you to stay up to date on what's happening. Cool. And wait, can someone confirm you're seeing my screen? Because I know there was... Okay.
Yeah, we can see it.
Thank you. So if you see this picture on the top left, that's a little kit. So the GT Makery, we found a nice Amazon kit that has quite a few different Arduino parts that kind of correlate to a lot of the workshops we do. So you can find that at tinyurl.com/gtmakerykit. It's not required that you get one of these kits, but it'll be pretty helpful and it'll help you to be able to follow along during the workshops. We're going to do our best to do workshops that you can also do virtually via Tinkercad, which Tinkercad is like an online Arduino software. But if you can get something physical, it'll be a little bit more engaging to participate with us. And if you're not able to get the GT Makery kit, we also have parts rentals, which I'll get into at the end of the workshop when I talk about what we'll be doing next week. Cool. So that wraps up kind of a summary of the club. So does anyone have any questions before we get started with the actual workshop content? Feel free to unmute or just put it in the chat. Cool, I'll go ahead and move on then. So, the first thing we'll do is let's figure out how can we use a microphone. So, it's actually really simple. The microphone uses analog data, and you can just analog read, and you just pass in the pin number. Hey, here, no worries, we're just starting the actual workshop content, so you haven't missed too much. Okay, now let me try to switch the view for y'all so that y'all can see my code. Okay, so let's go ahead and transition here. Okay, so for the mic, what we'll do is I'll quickly show the wiring of it. So let me take this out and okay. So right here. Okay, I'm gonna try to get this in the camera. Cool. No, don't bother zooming. Okay. Nope. There we go. So you can see there's 3 pins, and it's labeled out, ground, and VCC. Sorry about the glare. I'm trying my best to keep it in front of the camera. But yeah, there you can see those 3 pins. So I will just plug that into 3 rows on the breadboard. So this on the breadboard, for if any of you have not seen a breadboard before, I should go over it. These little rows of 5, they are each connected to each other. So if I plug in like something, like anything that goes in one of these rows, if I plug in 2 wires to both of those rows, you can assume that those wires are like connected beneath the plastic. Or yeah, these would be columns in your perspective. Yeah, okay. And then here you have a minus and a plus rail going like across the edge. So that's like your ground rail and your power rail. So what you'll usually do is you will take a ground pin from the Arduino. So right here, that way. This blue wire is plugged into a ground pin and they have labels, and the red one is on the 5-volt pin. So what you'll do is you'll take your ground and you'll put it in the ground rail, and the 5-volt and you'll put it in the power rail. So I'll bring that up just so you can see it. So we have from here, it's in the 5 volt and the ground coming to here to our minus rail and our positive rail. And that way it gives us access to, it basically allows you to plug a lot of different things into that ground rail with just one sort, the ground comes in one port from the Arduino, and then you have 24 other little ports that you can plug stuff in if you need to plug it into the ground. Okay, so we have our ground and power, and then I will just put the mic into 3 different pins of the breadboard. So you can see right here, right here, it's taking up 3 columns for the mic. And so the leftmost one is, or actually I'll do the rightmost one first. So the rightmost one is for the voltage in. So I'll plug another thing into that same column, and I'll plug it into the power rail. So right here, it's coming in to that. The power pin, which is the rightmost for the mic, goes, so I have another thing in that column, and then it's going into the power rail on the right. And I'll do the same thing for the middle. So the middle pin of the mic is for the ground. And there, if you probably can't see it, but now the little lights on the mic have turned on. And so now we need to get our actual data from the mic into the Arduino. So I'll plug in this green wire into the leftmost pin of the mic, and I can just pick any analog pin on the Arduino. So I'm just saying analog, so there's 2 things, analog and digital. So analog is kind of like, it detects a voltage level between 0 and 5 volts, but it maps those values to 0 to 1023. So that's 10 bits of binary data. And so if you call this analog read function on the analog pin, you'll get a value between 0 and 1023. And digital pins are different because they are either 0 or 1, low or high. And so then for the mic, we want to use analog because we want to get what is the volume reading of the mic. Okay. So the first thing we'll do in our code is serial.begin 9600. So what that does is it just initializes the serial monitor, and the serial monitor is this guy on the top right of your screen. So that'll just print out whatever data that we want to print out from the Arduino. So using the serial.begin, we'll basically just initialize that. It'll make the serial monitor work. So this thing to the right is called the serial monitor. You can open it from tools, and then the menu isn't showing up, but under tools there's something called serial monitor, which you can just click on to open that. What the? Don't know. Okay, so the next thing we'll do is we will read in the value. So we'll just do int mic level, and then we can do analog read, and then we have to pass in which analog pin we want to read from. So then if we look at the Arduino, you can see that the green wire is plugged into A2. So we'll just write A2 right here, and then we will just serial.println the mic level. And then I can just hit upload, and it's asking me to save the sketch. I will just save it to my desktop for the sake of being quick. Okay. Cool. So you can see on the left here it says done uploading, and now you can see that if you see on the right, it's just repeatedly printing 32. And so now if I speak, it's kind of like it has higher numbers. It's occasionally saying 1023. And so it's a little bit weird right now, but yeah, so when you're actually doing it, it's better to use a like a moving average of the values so that it's not so noisy. But if you see when I'm speaking, the values are just like going up seemingly randomly. But once we write some of the code for our actual demo, you'll see how we take these values and make them neater. Cool. So yeah, that's pretty much it for the mic. So now let's move on to how to use a NeoPixel matrix. Okay, so here is a NeoPixel matrix. So on the right we have a little picture. So here we have an 8x8, and then we have 3 wires for incoming to the matrix and 3 wires going out. So the 3 going out are used if you wanted to chain these matrices together. So you could have a bunch of LED matrices like all next to each other, and then you just plug the out of one into the in of the other, and then you can index any LED within the matrix on any one of the matrices and turn on that specific LED to a specific color you want. And so to do that, we'll need 3 includes. So including is kind of like importing a library, and so C or Arduino uses a slightly modified version of C++. So we use #include or #include to import libraries, and then just in chevrons or less than greater than symbols you put in your library name. Okay. And then so here we did the include, and then right here these 3 define statements, these are just creating constants. So we have a width of 8, a height of 8, and this is just a little constant to represent what pin the matrix is on. So it's on pin 2, so that's digital pin 2, because digital pins by default are just like a number, and then analog pins are A and then a number. So this 2 is just digital pin 2. And then right here we are creating a Neo matrix object, and here we just put in a bunch of configuration values. So the first 2 parameters are the width and height, and the third one is the actual pin for like which digital pin we're using. And then this next parameter is a little bit complicated, so it's bottom, left, and then rows and zigzag. So the reasoning behind that is essentially right here. Okay, let's see if I can get you a better view so that you can see what I'm looking at. Yeah. Okay. So right here, if you see, there's these little white arrows on the sides, like a little loop back. I'm going to try my best to keep this in the frame. So yeah, you see right here there's like a little white arrow that goes like that. So that's basically telling us the LEDs are like in a zigzag pattern. It goes back and forth rather than like individual rows. So that's where the rows and zigzag comes from. And then there's also a little indicator right here. So 3 dots and then an arrow going away. And that's relative to like the orientation of the NeoPixel matrix that's on the bottom left of the matrix. And so then that's why we have bottom plus left and then rows and zigzag. And then Neo GRB plus Neo 800 kilohertz is just like some configuration stuff that like it kind of tells the NeoPixel like the format of the LED stuff. Okay, so for your setup, so if you noticed in the code, I can actually go ahead and switch to that. So we have to initialize the matrix. So let's go to here. So if you remember, for our for the mic, we had a setup method and a loop method. So the setup method just runs once when the Arduino turns on, and then the loop method is what runs over and over. So then for the NeoPixel, what we do in our setup is matrix.begin, and that kind of just like gets the matrix ready for drawing to each individual pixel and like displaying what the matrix values are. And so that's kind of similar to serial.begin. And then in the loop, whenever you want to draw to a certain pixel, you use matrix.drawPixel, and then you pass in an x and y coordinate, and the little config variables that we made with like the bottom left row zigzag, that'll handle which actual LED gets turned on. So it simplifies it for us. All we have to do is x, y. And then and then the second parameter you pass in is matrix dot capital C color, and then the RGB values for that color. And then the most important thing to remember is matrix dot show. That'll actually make the matrix update all the pixel values. So the one thing that's nice is that you can draw a pixel to like 10 different pixels, and then only at the end you do matrix dot show. And that way you won't really see each individual pixel turn on one by one. It'll just be as if all 10 changed at once. So let's go ahead and try to code that. Yeah. So a lot of times when you're doing like an Arduino project for the first time and you're using a new library, you'll want to open the library manager that Arduino has. So it's under Tools, and unfortunately it won't show the actual menu, but under Tools you can click Manage Libraries, and that'll bring up a little window. And I believe you guys should see that window. No, you're not seeing it. Okay, here, let me give you the window. There we go. So here you can see the window, and right here we want the Arduino, or the Adafruit NeoPixel and NeoMatrix. So we'll search NeoMatrix, and then it comes up. I already have it installed, but usually you can just click this install button, and you want to do that for any libraries that you'll need. Okay, so what we'll do is just import all of our libraries. So let me grab these 3 import statements, and we'll just drop them at the top. And then the next thing we had to do is create some constants. So our width, height, and which pin we're using. And then here we are initializing the actual matrix object. So we'll just type in NeoMatrix, matrix, Adafruit matrix, and then all the other parameters we talked about. I know this workshop might feel a little bit weird so far just because you aren't really able to do a whole lot. You're mainly just watching me. But I promise that our future workshops will be a lot better. We're going to have parts rentals for you so you guys can actually participate. And if you get the little kit, you'll also be able to participate more. Yeah, apologies about that if you are getting a little bit bored not being able to do stuff by yourself. Okay. And then the next thing we'll do is we'll do the little begin function for our matrix object. And then in our loop, let's just draw something. So what I'll do is I'll just copy over a little function I made that will draw a smile. So this function that I just pasted, the first thing it does is it fills the entire screen with 0, which is just like off. And then what we do is, this is just a little piece of code that I made to draw like a little smile. So looking at the LED matrix, it would, how do I show this? Okay. It would draw a little smile that just comes and like turns on the LEDs in a little smile shape. And so then in our loop code, we will just call draw smile. Okay. And so now let's actually do the wiring for our NeoPixel. So let me show you right here. It's a little bit hard to see. It's under a bunch of wires. But we have a 5-volt ground and data in. So red is 5 volt, white is ground, and green is data in. So I didn't have a white wire, so I'll just use this yellow one. So 5 volt, we'll plug it anywhere on the power rail. Yellow can go anywhere on the power rail. And then green will, if you remember in the code, we used port 2. So we'll plug it into digital pin 2. And then we can just leave the mic there, it's not going to do anything. Okay. So now let's try to upload this code to the Arduino. And so now you can see a little smile. It might be a little bit like glary. Hopefully you guys can see the smile. But yeah. Okay, I'll have to bring everything to the top. There we go. There we go. So
The matrix is upside down right now. So.
there we go. There we go. We got a smile on our matrix. Yeah. So does anyone have any questions about what I've done so far? And feel free to unmute or put it in chat if you have a question.
Are you guys planning on putting the code somewhere? Just because I didn't get time to copy it.
Yeah, so we'll make the YouTube video, and then that's actually a good idea. We can also put like our code files in a little GitHub repo, and we can just link that in the description of the video.
Awesome.
And then we also always send out the slides. So if you just need like the little short snippets of code, those will be there as well. Okay. So that about wraps it up for how to kind of control the NeoPixel itself. So I think we can go ahead and try to make our face mask. So let's see. Let's switch back to our slideshow. Okay. So now we'll create an LED face mask. So the first thing you'll need is a mask that has like a little pocket in it, which I can grab in a sec. Yeah. So this mask has like a little opening, or I don't know where the best place to show it is. There's like a little opening where you can put something. So eventually we would put this guy right in here, and it would look like I'm smiling. I know it's a little bit offset right now, but that's the idea. Okay. And then you'll need, so this next one is technically optional. You can mount the electronics however you want to, but we'll be using this headband. And so this headband has like a little elastic part in the back instead of being like clothed all the way around. So this gives us a nice little place to mount the electronics, which we'll show you how we're doing. And then we're going to program it on this Arduino Uno, which is a little bit larger, but you can also use an Arduino Nano, which is a lot smaller, and that way you can have it like be more portable, because obviously sticking this giant Arduino Uno onto your head is probably a little bit cumbersome. And then you'll need this little mic and this NeoPixel matrix, obviously, and you'll just need some wires. So yeah, here is an Arduino Nano right there. So it's a lot smaller, but it has all the same pins and functionality. It's just way more condensed. Cool. And we have a couple links here at the bottom. We can send those in the chat. So the first one is for an Arduino Nano, and I believe that link is for 3 Arduino Nanos, but oddly enough, buying in bulk is literally the same price as buying individually for Arduino Nanos and a lot of different Arduino products. So it's a link for 3 Arduino Nanos, and then the LED matrix link is just for this exact one that we bought. And the Arduino mic, I believe, is also a 6-pack. But yeah, so I'll first kind of do this wiring. So the first step is wiring, which we pretty much already have. I'm going to go ahead and switch the mic into A4 because that's the port I used when I made this demo, so that'll just be simpler. I won't have to change a bunch of constants. And then we want to import the NeoPixel and NeoMatrix libraries, which we've already done for the matrix demo. And then the first thing you'll do is you'll create your little matrix objects and define whatever constants or variables you need. And then that kind of wraps it up. All you have to do from there is code your mouse movement. So I'll go ahead and switch back to our code. Yeah. So I will actually make the, yeah, I think that should be fine. So can everyone see the code as everyone kind of knows where we are right now? Yeah. Okay, let me flip this camera horizontally so that it reflects what we're looking at. Cool. Okay. So the first thing we want to do is we want to kind of move our mic reading function into separate separate functions so that we can just call them from our loop. So I will move your laptop a bit. So right here I will just create a function that returns long called read mic. And what that's going to do is it'll so one thing that's also important for analog reading from your mic is that it's good to sum over 100 different reads of the mic itself. So right here we'll just do long sum equals 0, and then here I'll actually just paste the code. There's right there. So right here what we're doing is just 100 times we're taking the analog read from the mic pin, and then we're just taking the average by dividing it by 100 again. And that gives us a better value, and that's why if you remember it was 32 and then 1023 and just jumping back and forth. So by taking this average over 100 readings, it'll be a more meaningful value between 32 and 1023. And so the next thing I'll do is we actually need to create some constants for our mic. So let's pound define our pin for the mic as A4, and then yeah, that's all we need for now. And then another thing that you can do is use a moving average for your mic value. However, when we were testing, we actually ended up not needing that, so I will, for the sake of time, I won't really explain that, but it will be in the code when we post it if you want to look at that. But yeah, for now we'll just use the little read mic function as our all we need. And so the next thing we want to do is, if you notice, this thing is only 8 by 8. So obviously we can't make a separate mouth shape for 0 to 1023 because we only have an 8 by 8 matrix. So what we'll do is we'll actually just reduce it down to 4 states. So it'll be a closed mouth, and then a little bit open, and then slightly more and more open, with a max of 4 being a full circle. So what we'll do is we'll just create a constant for our mic states, or for our maximum number of mic states. And so we could just hard code this value 4 wherever we use it in our code, but the point of having a little constant is if we got a bigger matrix, we could just change this little constant, and that would it would kind of make a lot of the code already work for a bigger matrix that you wouldn't need to change a lot of your code for. Okay. And then so let's just try to, so the next thing we need to do is map our mic level to an actual value between 0 and 3. Since we have 4 mic states, we want 0 up to 3. So here I will just create a function that will do that. So get volume interval is going to be our function, and we'll pass in a mic level. And I know this function is kind of long and hard to look at, but what it's doing is we're taking the current mic level and we're subtracting the minimum volume. So if you remember, there was a bunch of 32s in the serial monitor before, so now we'll have an actual min volume, and that'll be kind of our threshold for opening the mouth. And so this will get us how far above the minimum we are. And then the first thing we do is multiply by the number of mic states minus 1, so that'll be times 3, and then you want to divide it by the total range of volume, so max minus min. So this is, you might have seen this function, it's like a mapping function. It maps from one range to another range, and then this is just kind of a more the second range is predefined with constants, so there's not as many parameters, which is why it looks a little bit weird. So yeah, so this will give us a volume interval. So now let's just try to, in our loop, let's try to just serial.print our mic interval. So we will do get volume interval, and then right here we'll pass in the value from read mic. And then, oh, so I think I forgot to define the min and max volumes, so I will quickly add those in. So these two min and max values are basically just testing. So we noticed that 80 and 750 work the best, but if you create this on your own, you might find a different pair of values that work the best for your configuration. So I just hit this button to compile and download to the Arduino. And I will go ahead and pull up the serial monitor so that you guys can see what values are being printed. So you can see there's a bunch of zeros, and then hopefully once I get closer, it'll start to kind of go up between like 0 to 3 and sometimes 2. Yeah. So if you notice, I had to get pretty close to the mic for it to pick up and like show higher values. But yeah, so we'll use that to control the display on the smile, or on the matrix. So the next thing we want to do is we want to create a function that, given a certain mic level, it will draw the mouth at that level. So let me just pull up my little draw mouth function. So right here is a function to draw the mouth, and it'll just take in a parameter called openness. And this openness is the same like 0 to 3 that we got from our volume interval function. And so here the actual implementation is not super important. It's just like when it's volume 0, it's just 2 lines, and then when it's openness value of 1, it just opens by like in the middle, it's up by 1. So then there's like a gap of 2 lines in between. And then, yeah, I think I can just draw it and you guys, or I can just run it and you guys will see what I mean. So right now I'm just going to make it store into a variable instead of immediately printing. And then what we'll do is we will call draw mouth and we'll pass in our level. And we'll just comment that out for now. And so the shortcut I used was Control/, and that'll just toggle it into a comment. I think it's, yeah. So you can see that it's closed, and then if I speak into it, it starts to open. So right now we're halfway there. We got a thing to open as I speak. So now it's just a matter of so we wanted to show us a little smile. So one thing you can do is, if you haven't spoken in a while, we can just have it display like a little smiley face, and that way, just like when you're quiet, it's not just like a boring line, it'll be a smile. So you look happy, even if you're sad. Maybe you can make it display a frowny face if you're sad. Okay, so what we'll do for that is we'll just maintain. So we had a couple different ideas for how we could determine like when to go silent. The best way we thought of was maintaining a variable of the last time that like the user says something, or like the last time they make audible volume. So for that, we'll just create a variable that just is called last speak, and that'll just hold the milliseconds value for the last time the person said something. So it'll just start as 0. There shouldn't be a slash. Cool. And then here, what we'll do is if the level is greater than 0, then we want to set last speak equal. Oh, I missed the 0, sorry. So if it's greater than 0, we will update the last speak. So millis is a function in Arduino that just returns the current time on the machine. And then we also want to draw the mouth. So right here, that'll be level. And then else, which means it's like it's at level 0. We'll add an extra else if to draw the smile. Draw a smile. So what do we want this condition to be? We want this condition to be, so actually I need a reference to the current time again. So what I'll do is I'll declare a variable before we start doing this. So long curve time equals millis, and that way I can reference it twice and be guaranteed that it's the same value. Speak. So that's like how long it's been since the last time we spoke, and now we can create ourselves a little constant for how long we want it to wait before we do a little smile. So I'll jump to the top. I used control home to do that. So I'll just define my smile delay as 500 milliseconds. So if I'm silent for half a second, it'll just switch to the smile. And then else we will draw a mouth with level, which in this case would be 0, so I'll actually just pass in a 0 right here. So this else block would only run if the mic level is 0 and we're within 500 milliseconds of the last time we spoke. Okay. So now let's try to run this. So you can see it's uploading and it's done. So if you saw, it kind of switched to a smile pretty quick. And so if I speak, it starts to open as I'm talking, and then it switches to the smile when I stop. I'm speaking, and then when I stop, it goes to the smile. So yeah, we've pretty much done it. We have a working LED matrix for when the mic is going off. So now let's kind of get into how are we going to put it together and actually make a mask out of it, because obviously you can't really stick this to your face and you don't want to mount these two huge things onto your face. So I'm actually gonna, Sure. So we'll actually have Pulkit, he'll come and show us how to put it together. So we come this way.
Alright, so I'm gonna basically talk through the parts we're gonna use. So we had the Arduino Uno right here. What I've done is I've taken an Arduino Nano and we put the same code on it, and I've just taped it to a mini breadboard. And then I've just stuffed all the wires in. So if you wanted to make this on an actual headband, you would, instead of like using a breadboard, you would just solder your wires directly to this Nano. But since we don't want to kind of deal with soldering today, what I'm going to cover is just how to basically mount everything. So what I've done is I've put a piece of electrical tape on this breadboard such that when I open the tape, I don't know how well you guys can see this, but I've got like a double taped region right here that's not sticky. And what I can do with that is I can put it on my headband, and then I can tape my Arduino to the headband in a way so if you guys can see this, it can slide on the headband. That way it's not gonna like pull or anything when we are, I guess, wearing it. So the next thing we need is a power source, because we don't really want to be walking around with a like USB power bank and then a wire going up to our head. So I've done the same thing with a 9-volt battery, which is right here. And we're going to do the exact same thing again. Make sure that this is going to go on there. Yep. Okay. So we'll take this and we'll tape this 9-volt on. And we can see that the 9-volt can also move around. So next is putting the mask together. So if I have my mask, what we're going to do is just unplug from the Arduino here. So I'm going to unplug the mask and push this Arduino off to the side. So we've got our LED matrix, and then I've just got the mic, same mic, just connected to some wires. So we're going to take the LED matrix and we'll open up our mask, open up the pocket, and we'll push our matrix down in here, roughly where we think our mouth is going to be. We'll adjust it once we put it on. Yeah. All right, so we've got a mask with a matrix in it. Obviously, you can't really see anything on it right now, so we'll get that fixed real quick. So I don't know if you guys remember from the diagram of the face mask, but it had a like jumper connector on it as well. So we desoldered that and just connected that to some wires to the Arduino, and we can plug it in. All right, and then we can take our other wires, which is this microphone, and what we would want is to put the microphone directly in front of where our mouth will be in the mask. And we'll take these wires, and so I've kind of marked black, red, and yellow, and I'm going to hook that up to this right here. So we are now connected, hopefully. All right, so now we can go ahead and hook up our power, and we can see that we have our mask right here. So in the orientation of someone wearing it, it'll be like this. And if I talk into this, we can see that the mic, it reads the mic volume and it opens the mouth as we need. So let's get back into here. You want to wear it?
I already put it on.
Okay. All right, so I'll let it be our test person for this. So Mudit, go ahead and put it on.
Okay.
So the way you'll put it on is it's a bit of a hassle, but basically you're going to lean forward and put the headband on first. All right, so we're
Okay. Well, my hair looks a little bit weird
Yeah.
in this headband right now. Okay. So, I will just fix the headband and I will put this mask on. So obviously if you have less hair, this is probably easier to put on. But I have a lot of hair. Okay, so I think I accidentally took the mic out. So let's go.
Which
ahead
is
and
fine.
fix
We
that.
can position the mic again in a sec. Let's go ahead and move the smile into the right place first. So you'll have to go into the pocket with your fingers and fiddle around with the matrix and get that in place.
Right now our smile is a little bit tilted. So what we'll try to do is... Nope, I think I just made it worse. I think that's a little bit more vertical now. And
All right,
then...
it's just a little off center. And we'll take the mic and we'll put it behind the matrix so that the mic is basically right in front of your mouth. Need help?
Okay. We just stick it right in there. And so now I can feel the mic just like right in front of my mouth. And you can see it's already kind of working, but it looks silly because it's tilted right now. So let's go ahead and switch views to a better display of it. Yeah, so you can see me. Geez, my hair looks really bad right now. Okay. So yeah, as you can see, this takes a little bit of fiddling to get it to look exactly correct, but now you can see that it's kind of working, but you can see that the mouth looks a little bit weird. It's not always like opening to the max level even when I'm talking. So if you like notice how it's almost always only going up to the third level, and only if I'm like really loud does it go to like that top thing that only has two things at the very top. So what we can actually do to fix that is, let me quickly just make this look a little bit better. Okay, so what we'll do is we'll come right up here and we will update our max volume. So right now the code, the max volume is a little bit too high. So we would want to decrease that to maybe like 600, and then we can try to
This
re-download
is
the
gonna be
code.
interesting. Is this the
Yeah.
plug this in?
So we are having to switch the wires. Hopefully we're able to re-download.
You'll have to change the port type.
Okay. So my brother's just gonna plug this into the Nano, and then thankfully you only have to do this when you're setting it up. Okay, and it should be plugged in. So in our tools, we're just gonna make sure we have the correct port selected, and then we're going to upload the sketch. And hopefully I chose the right one. Yeah, I did. So the code is now on this little Nano, and you can see that it's still not as good, but it is opening to the max level a little bit more. So maybe if we decrease it a bit more. Oh, you just unplugged it.
That's fine.
So let's try maybe 500. And what I can actually do is, yeah, I'll go ahead and do this. I will,
The serial function.
yeah. Is I will serial print the mic level so that we can kind of just look at the values themselves, and we can maybe get a better judgment of what our min and max should be. So here you can, right now you can see as a lot of planning can go into an Arduino project, but there's always our debugging involved no matter how much you do. Okay. Now we will just upload this sketch. And let me go ahead and update this. Okay, I'm going to move it over so that you guys can see the serial monitor. Cool. So it looks like there was an error.
Oh, just hit upload again.
Yeah. So there was some sort of upload error. We're just going to try to upload again and see if that goes away. Seems like it did. Cool. So now, as we talk, it is actually seeming a little bit better. And so something we can do is actually open the serial plotter. So if you're only plotting numbers, you can actually see a graph of your values instead of just a bunch of numbers. So as you can imagine, this probably isn't that useful. It's just a bunch of random numbers flying through the screen. It's hard to tell what like the mins and maxes are. So what we'll do is we will close the serial monitor, and I will pull up something called the serial plotter. And I think I'll have to quickly set something up for y'all to see that. Okay. So it looks a little bit weird because, okay, I'm gonna go as fast as I can to get this up for y'all. Okay, sorry about the delay. I am gonna make this look. Okay, so now I will put this right here. Okay, so now you can see a graph. So now if we look, you can kind of see the actual spikes when I'm talking. So let's maybe find like a good maximum value. Actually, what do y'all think? Do you think that the lights are kind of reflecting when I'm moving my mouth? Do you think it should be moving, like it should be opening more, it should be opening less? What do y'all think? Or do you think it looks good? Looking like the Cookie Monster, yeah. I think that's pretty good. Cool. Well, in that case, then we can go ahead and just unplug the Nano. So we'll let Jack do that. Cool. So now, let's go ahead and just switch back to the view of just me. Yeah, and it's done. We have made a little self-modulating mask. You can see that I can kind of move around. I'm not connected to anything. There's no wires. And yeah, I can just...
So you can see when it turns its head that like there's like wires sticking out,
There's
right?
probably a bunch of hair everywhere.
Yeah. So you could take the wires and like put them over your ear and hide it behind the band, or if you like want to put more effort into it, you can actually just run the wire along the band so that it's like less visible.
Yes. Yeah. Okay. So yeah, that wraps up the learning that we had to do for this workshop. So now I will just give you guys some updates about next week, and I'll kind of explain what the rental process would look like for parts.
Wait, we have a few questions.
You have questions?
Yeah, could you do like a smaller battery?
Could you do a smaller battery?
Yeah, you could. So instead of using a 9-volt cell, you can use like a coin battery or a handful of like. I would use a coin battery, so you could use like 2 coin batteries. That'll give you 6 volts, which is enough to run the Arduino. You could probably, I think that's probably the smallest battery you could get. You could maybe buy like a mini like lithium-ion battery and use that. But yeah, there's no restriction as long as it gives you enough volts.
Yeah, so LEDs would burn through the battery pretty quickly, but you're probably not going to be using some big flashy thing as wearable tech. Wearable tech is usually a little bit more subtle, so hopefully LEDs wouldn't be a huge issue with eating through your battery life. Yeah, but I mean, yes, I agree. Okay, so let's go ahead and look at some of these updates. Okay. So, let's go ahead and talk about next Tuesday. So, next Tuesday we will be having a workshop. So I know we said like we're going to be alternating Tuesdays and Thursdays. That's actually going to be starting with our next meeting, since today was kind of like a off schedule, like our first meeting of the semester. So next Tuesday we'll be doing a Valentine's Day workshop. I know that's a little bit early, but it's just so that once we do the workshop, you guys have time to maybe buy some materials and actually make something for Valentine's Day if you have a special someone to give something to. So you can see we have a couple pictures around the slide of different acrylic displays. So we'll be learning how to use Inkscape, which is an SVG editor, to create a shape and also do engravings on the acrylic. And then you can laser cut your shape and then stick it in a little like mounting display, and it just has LEDs along the bottom of the display, and those lights kind of just shine through the acrylic sheet. And yeah. So yeah, let me actually give a little bit more information. So for this workshop, we will be renting out parts, and that way you guys can participate a little bit more. So we'll be giving you a little breadboard and some LEDs along with a 3D printed mount for an acrylic sheet. And then we'll also be giving you guys some 3" by 3" acrylic sheets that, unfortunately, the laser cutter in our workshop was broken by someone. I promise it wasn't us. It was someone, I think, during the last summer broke the machine when they were trying to repair it or something. But there are still other maker spaces on the campus that you can use to get your acrylic sheet kind of carved and engraved. And then you can stick that into the little display we're going to give you. Unfortunately, we can't let you keep all of the stuff in the kit. You'll have to give some things back, and we'll have more information on that. Jack can send the link in the chat. It's gtmakery.github.io/rentals. And if you can't remember the rentals, if you just go to gtmakery.github.io, it'll have a secondary link that'll take you to the rentals page. Right now there's very little styling on that website. Don't blame us, we're working on it. But yeah, you can just fill out that rental form. We just have a couple questions like name and email. And then once people respond, we will get back to you as soon as we can. And as many parts as we have available, we'll get as many people able to participate with the physical objects that we have. And yeah, I think that wraps it up. Yeah, if you just go to gtmakery.github.io, we'll have like separate links that go to each of our Discord, Slack, mailing list, and everything like that. So make sure to do that so that you guys can stay up to date about the rest of our meetings. And with that, that wraps it up. Thank you. We'll see you guys next Tuesday for our Valentine's Day workshop. Once again, it's at gtmakery.github.io/bluejeans. And we have all the links on screen.
Bye, guys.
Thank you everyone for coming, and I hope you had a great time and you learned something.